Hello and welcome back to our webcast series on perspective projection. In this video we're going to look at applying the theory behind our datum height lines, which we had seen in our last video. So we're going to try and put that into kind of a practical question. So the question that you can see we're going to apply is the example here of a house. So we have the main building of a house and we have a small extension added onto it. So here's the 3D view of that object and here's the plan view seen from above. So there's the roof of the main building and here we have the roof of our extension jutting out of that. So the question, as you can see, is kind of already set up. We have our vanishing points located by taking our two directions that we have in the object and going parallel from our spectator and locating VP1 and VP2. You can also see from the question, if we look at the object that we're trying to draw, none of the edges or corners of our objects are resting against the picture plane. So that means that all the edges are going to be foreshortened. They're not going to be the original size that we have in the question. So this is why we need to apply our temporary datum height line. We need to locate an original height to begin with to locate one of these corners on our building, and once we have that we're able to continue on constructing the object as normal. So when it comes to taking our datum height line, we I suppose have a couple of options for it. We had mentioned in the last video that you're not restricted where you place your datum height line, as long as you have a vanishing point to move you back in the direction that you're dealing with, so either this direction here or this direction here, you can take your height line from any number of positions. But as with most questions, looking at the question, there's possibly an easy way to do it, or a way to reduce the amount of work that you have to create it. And we'll just talk a little bit about that at the start here. If you look at your object like so, we could take our datum height from any number of positions. We could take, say, this line here, this edge, say what would be, I suppose, the gutter of our building, and we could continue that on until it hits the picture plane and create a datum height line for this surface here like that. Likewise, we could do the same thing with the likes of our ridge of our house. We could continue him on and we could create a second datum height line there. We could do the same for the gutter on the far side here, continue that on until it hits the picture plane and create a third datum height line. Now, and that will work perfectly well. We have a vanishing point, VP1 here, which will get us in that direction. So if I was to continue this on here, that would be a datum height line here. I could project that up. I could mark off my distance and go back to VP1, and that would be perfectly acceptable. The only disadvantage about that is that you need to create a datum height line for every single edge. You need to create a datum height line for this edge here. You need to create one for the ridge height. You need to create another one for the ridge height of our extension. You need to create another one here for our gutter, like so. So you end up with quite a few datum height lines, and that's not a problem, but it's, I suppose, extra work that we might not need to have to do. If we look at our object like so, you can see if I take this edge here, so this is our main front face of our main building like that. Well, if I was to create a datum height line by continuing that edge or that surface along, so a datum height line out over here, well, every height that I could have could be brought along that. So that would actually locate me the height of the gutter here, the height of the ridge here, the height of the gutter and the ridge for my extension, and the likes of the gutter for both the extension and the main building here. So if I was to create a height line using this surface, all my heights could be used on that one height line. So we're trying to reduce the amount of work that we're actually doing. Now some people find that, you know, if there's too many heights, they might find that if they're too close together that it might get confusing, and they might decide, you know, for convenience sake, they might take maybe two separate datum height lines and just kind of maybe reduce the amount of information on one single line. And again, that's perfectly acceptable, but for a question like this, there's not too many height lines, so it makes more sense to just take one single height line. As I say, this is just a suggestion, not necessarily, you know, an ironclad rule or like that. Sometimes you find it is easier just to separate things out, maybe to have less information on each height lines. Up to yourself. But so we'll just put that into practice here and just show you exactly what we mean. So if you take our object and we're going to create our datum height line by taking our surface, our plane of our house, and we're continuing it along here like that. So it's moving in this direction, so you can follow our lines. We can see that that means vanishing point 2 is going to deal with lines moving in this direction. So where that hits our picture plane gives us the position of our datum height line. So here it is in our 3D view. What we've essentially done is created a plane, like a sheet of glass, cutting along that surface there. So where that crosses our picture plane gives us our datum height line. So there it is, there like that. You can see I've just transferred each of the heights of my building across. So there's the gutter, there's the ridge of my extension, there's the gutter for my extension, and all the heights there are now marked on this datum height line. And because that's on the picture plane, like we saw in the last video, that means that they're all going to be the original height in our perspective view. So there's our datum height line in our 3D view. There it is as a point in our plan view here, in our 2D. We project it up. The ground line represents a height of 0, so we're able to draw up our height line, and there it is, continued back to our vanishing point 2. So the plane that we can see here, this green plane, there is the exact same thing in our perspective view, tailing off into the distance. So there's our height of 0, there's the top of our height line like that. I mean, we haven't got any particular height there at the moment. But you can see what I'm doing is I'm marking off each of these heights. So my original height, so the height of the gutter, the height of the ridge, the gutter of the main building, the ridge of the main building, and I'm just marking them off on my height line and bringing each of them back to my vanishing point. So there's height 0, height 1, height 2, height 3, height 4, all going off back into the distance, moving in this direction here, like so. So that's my VP2. So that's exactly the same thing there seen in our 3D view. So there's our height line drawn on our picture plane going back to VP2. So remember, these lines here are drawn on the picture plane. So with that, all we really need to do then is just locate the edges that we're dealing with. So the moment we want to find the edges along this surface here, we have the heights for this surface here. So we want to find the position of our corner here, the ridge here, the ridge here, the gutter here, the gutter here. And we do that exactly the same way as we had seen before. We take our points and we project them down to our spectator where it crosses the picture plane, bring it up. So there's our front corner here like that on the main building. There's our front corner like so. We can see it goes from the ground here up to H3, so height 3. And there is our leading edge there. So that's our first point. And like we had said before, once you have your first edge, the question really is just like any other perspective question. You have somewhere to start off with. So if we wanted to go and draw in our edge like so, again, there's our height 3. We'll be moving back along in this direction here. There it is there, going back to VP2. So now we locate our position, again, join back from our edge or our corner to our spectator, where it crosses the picture plane, bring it up. And there is that surface there like so. We can do the same with the ridge. So the ridge goes up and we can see we have our H4 or height 4 for the ridge height, and there is our gable end or the side of our house located. So side of our house located, you can see here we can do the same thing in our 3D view. There is just taking from our corner points to our spectator where it crosses the picture plane, gives us the image of the object. So that's the gable of the object. To draw in the rest of the object going back into the distance, we go back to vanishing point 1. So there's our heights going back along. So there's our gutter moving back into the distance. There's our ridge going back to the distance. There's our ground line going back into the distance. And like before, to locate each of the points, we take it from our perspective view down onto the picture plane and then project it up into our perspective image. So there is the main portion of our house done. It's exactly the same thing then for extension. What we're going to do here is we're going to draw in our corner point here, so the corner edge of our building. We're going to locate the top point of our ridge here, and we're going to project them out in this direction here. So there's our 3D view filled in for the side of our object. So for the corner point, you can see we take it down, project it up. So there is the corner of our building going from the ground up to H1. And like that, we said we wanted to project it out in this direction here. So our vanishing point 1 moves us in that direction. So there it is, continued out. And we take the front corner here, project it down, and then project it back up. And there is the side of our extension, like so. Again, we want to move our lines back in this direction here. So our gutter and our ground line going in this direction goes to vanishing point 2. We want to locate the back corner, and then we want to locate our ridge. Again, we're working from where we have our height line, so this is where our datum height line is located, so this is the point we're locating for our ridge. Projecting it out again, bringing it up, and you can see we have our extension drawn on like so. So same thing applies over here in our 3D view. Now I can understand there's a lot of lines there for the 3D view, but essentially we're doing exactly the same thing for each one of them. We just, once we have our height lines, we're just taking our points, bringing it to our spectator, and where it passes through the picture plane, that's where our image point is located. So there is our 3D view located there. So there's our perspective image on our picture plane in the 3D view, and there it is on our 2D view. And you can see we've just removed some of our lines there away because they won't be visible. So it's often quite useful just to keep your construction quite light at the beginning, and then you can darken in exactly what you know you're going to see afterwards. So tidy up your question. So that's our application there. And as I say, I mean, you can see we've created one plane using one height line, and every single height has been located on that. So I say one height line has done an awful lot in this particular position. We could have taken numerous height lines and use them individually. As I say, the only difference being is that it's a little bit maybe extra work. But as I say, if you want, and you find that sometimes you have too much information in the one height line, you want to separate it out, that's again perfectly acceptable. So as usual, I hope you found this useful, and hopefully we'll see you again soon. Take care.